All right, so for function notation, we have, let's say something like this. So f of x is how you read that. Read as f of x. Okay, so function notation read as f of x, you'll see things like this. So let's say we have f of x, and it just takes some getting used to, you'll pick it up. But f of x equals, and let's just, as an example, let's just take 3x plus 5. This is the same thing as what we've been seeing, but whenever you had a y, okay? So this is called function notation. And this is just our equation written in terms of x's and y's, okay? So function notation, think of it as, in a sense, it's a way to name functions. So you could have f of x, we'll see other letters, g of x, h of x. So this is just a way when we're working with multiple functions to name our equations instead of just having y over and over again. But this, this idea that these are equivalent, these are the same exact thing, only one is written in function notation and the other one is just our y equals equation. So what we want to do today, our goal, to solve an equation in function notation substitute, aka plug in, right? The given number, this is the last bit of writing, right? Substitute the given number for every value of x. All right. So some examples. Did y'all ever see function notation in middle school? Does that look familiar, that f of x?
No.
No, brand new? Love it. All right. Brand new. So it's not that bad. It looks a little scary, but this was like the day one of like the more, I guess we'll say the real algebra notation here. We've graduated. So let's say example 1, you're given the following. So we have f of x equals, and I'm just going to stay with this one for our first example. So we have f of x plus 5, and I'm going to ask you guys to find, and then this is the notation that y'all will see, find f of 8. All right, so to find f of 8, and just maybe because it's brand new, f of 8, just to help you, because when you're learning something new and you don't know the terminology, it makes you feel like more uncomfortable to ask questions about it because you feel less confident because you don't know, how to word it. So don't be afraid of that, guys. It's totally normal. But this is f of 8 is how we would read that. So we're trying to find, or sometimes I'll say evaluate. This is actually something that y'all completely know how to do. You've already been doing it, just not with this notation. When you look at this, and I'm telling y'all are the same, or telling y'all that these two things are the same. If f of x equals 3x plus 5 is the same as y equals 3x plus 5, then what is f of x really equal to? Like, what does f of x represent in this equation? Y. So f of x equals y, okay? F of x I'm going to say is the same as y, okay? It's another way of writing y. So instead of writing y equals, it's just naming the function and giving it that function notation. So f of x, it's equivalent to y. So what this is really saying, find f of 8, this is really asking us to figure out what is the y value when x is 8. And I'm going to show y'all that in a table in a second, so that way DESMOS can do some of this work for us. But if we think back to these problems that we looked at the beginning, to evaluate these by hand, because I'm going to show y'all two ways, one with DESMOS and one by hand. And you pick what you want. Earlier we were talking about it, and some students are going to want to do it by hand because they feel like it's easier and faster. Some students are going to want to evaluate this in DESMOS. So we're going to look at two different ways. But if we're evaluating it by hand, then what I'm going to do is take the value that they are showing me in the problem. So for us, it's f of 8. I'm going to take an 8, and everywhere I see an x in my problem, I'm going to replace it with that number. So for this guy, I'm going to take this 8, and instead of having f of x, I'm going to take that 8, and I'm going to substitute it everywhere I have an x. So for every value of x, I'm going to replace the x with an 8. All right. Are y'all okay with what I did here? I'm substituting, I'm replacing the value of x. I'm taking the value of x, and I'm just swapping them out with whatever this number is. Okay, so I'm swapping them out with whatever that number is. So instead of having f of x equals 3x plus 8, I have f of 8 equals 3 times 8 plus 5. So I am just replacing the x with whatever the number is that they showed me in the problem. It's just a straight up substitution. From there, just get what this number is. You can do that in the calculator. So DESMOS is probably our most friendly, right? 3 times 8 plus 5. So if we go over to DESMOS, and I have 3 times 8 plus 5, we get 29. So 29. That's your answer. That's all we're doing. If it asks you to evaluate, you're plugging in that number, substituting it, and simplifying. So this is how to do it by hand. And you just do the numbers in DESMOS. Let's do another. All right, another one. We're going to do several, don't worry. It's really not that hard, it just looks scary. Whoopsie, got ahead of myself on the G here. So our second one, this is read as G of X. Okay, so G of X. Find G of negative 5. So what we're going to do is we're going to take that negative 5 and we're going to replace every x that we have. So instead of G of X, we're going to have G of negative 5. Now, this G of negative 5 part, I know some of y'all are not going to want to write it over and over again, but look at it like you have to. Okay, it's just part of your problem. It's what your equation equals. It's what your function is equal to. So on the left, you just keep rewriting G of negative 5. That doesn't mean G times negative 5. That is just notation. That is naming our function, and we read this as we're trying to figure out what is G equal to, what is that function equal to when x is negative 5. And to do that, we're going to substitute in. So you would here, yes, but you could distribute, but since we're going to actually plug in a number, we're going to get just a whole, like a, well, not necessarily a whole number depending on the problem. Here it will be. But because we're just plugging it in, we could just substitute it straight in. You'd get the same answer if you distributed first, but because we're not solving for X, we're plugging in the value of X. We could just honestly go to the calculator and let the calculator do all of that work for us. So at that point, we could go to DESMOS and type that in. So our next one, just type it in the way we see it. So -2, and this is why I can't encourage y'all enough to just get DESMOS, because it does better than your phones with your regular phone calculators with all of the parentheses and the negative signs. All right, so when we simplify that one, we get -2. And so we're just plugging in and solving for that value of X. Okay, we're going to do one more. All right, this time we're going to have h of x. H of x. H of x equals 2x squared minus 4x. And we want you to find the value h of -4. All right. These are the trickiest ones when you have these negatives. You've got to be careful with these negatives and how you type them into the calculator. So when you substitute in this -4, remember, we're just replacing every value of x with a -4. So the 2 is still going to be there. We had 2 times. Now, x squared, I would just use parentheses here. But look at where I'm putting the squared on the outside of the parentheses, because we're not, the order of operations, when we do PEMDAS, your calculator won't know to not square just the 4 and then put the negative on it afterwards unless you put that squared out there. Now, when I'm encouraging you to use your DESMOS today, and I'm going to show you the other way of doing these. So this is the by hand way. That's the main reason I like the table that I'm going to show you in DESMOS, because then you don't have to worry about plugging in the negatives because it's going to figure it out for you. But let's just go ahead. If you're going to put this in DESMOS, I want to show you what that would look like, and then we'll switch to putting in our table. So guys, this is what you really need to be careful with. So watch how I'm going to type this in. So -4. And then I'm going to close my parentheses. And then for the squared, the little squared key is here. And then I have -4. And then in parentheses, -4. Close parentheses. So it'll figure it out for you. But look what I'm going to show you. This is the correct answer, right? But if you just do 2 times -4 and you square it, and then -4 times -4, look what you get. All right, look up here, guys. Look at the difference between these two things. Because I always have students, even in my Algebra 2 class, that feel like it doesn't matter and that you don't have to put the parentheses around your negative numbers. So when you're typing into the calculator and you want to square a negative number because you plugged in a negative number, you have to put the squared on the outside of parentheses. With your calculator, it's just doing straight up order of operations left to right. So it says, oh, exponent. I'm going to do my exponent first because you don't have any parentheses for PEMDAS. So it will mess you up every time. It's the main thing I freak out about when it comes to plugging in negative numbers. So this is wrong, okay? We do not want to do this. This bottom one is wrong. The top one's what you got to do if you're typing it into DESMOS. All right, so 48. So before I show y'all how to do it with the calculator, a different way in the calculator other than just typing it in like that. Questions on plugging in your numbers. How are y'all feeling about that? Like, you feel like it's easy? Is it looking confusing? Like, you got to give me some feedback because y'all are real quiet and I don't know if y'all have questions or not. Y'all are okay? Probably need to try some, but don't have any questions right now. Okay, well, let's look at the calculator real quick. So if we were going to do this in DESMOS, so we could use DESMOS table. I want to show you how to do this, so try to follow along. We're going to put this equation in DESMOS. Back out of all of this. So DESMOS will read f of x. So let's type in our equation. So f of x plus 5. Okay, so I'm just literally typing in exactly what they start you with here in DESMOS. This is how you get to your table. So watch does anybody know how to get to a table? I had to be taught because I was like, I don't know how to do a table in DESMOS. You put in your equation and then you click on this little gear icon. Now, which of these two things looks like a table? Yep, convert to table. Click on that, and then look what it's going to do for you. It's going to give you a table, the same way your old graphing calculators used to. But how you read it is very important. So we talked briefly, and I was trying not to confuse you, and I started like having to back off for a second. But we started kind of talking about how f of x is another way of writing y. It's the same thing as writing y. So what these questions are asking you to do when you have this notation, this is another way of asking ourselves, what is y when x is 8? Okay, what is y when x is 8? Because this whole notation means y. It's another way of writing y. So when you go, get off your phones, please. Too much texting going on. Unless you're using DESMOS. If you're using DESMOS, I'm thrilled. Something tells me some of y'all, I will not name, are not using DESMOS. If you're on DESMOS, you keep on going. I'm happy about that. If you're texting your girlfriend, your boyfriend, then put that on hold. All right, but this table is interactive. So you can write over these numbers, or you can come down here and type in a new number. So if you're trying to evaluate f of x for when x is 8, so I want f of 8, I'm trying to figure out what is y, what is the y value when x is 8. So if I just put in that x value, so look, compare these two, right? When x is 8, because we're plugging in an 8 for x, what is y equal to? Well, that's what that notation is, f of 8. So when x is 8, y, f of x, is 29. So from the table, you can just plug in, write your function in there, plug in the x value that you were substituting in by hand. And if you want to skip the doing it by hand, you can just grab it from your table. So put your equation into, the top box, click the little gear icon, and then type in the value of x that you're trying to see what the y value is equal to. We're going to do another one, but questions on this one. So this is how you check. Like, this is a check, or you can do the problems in here. And this is good for like a couple problems where if you had to find like 5 different, f of 2, f of 7, and you don't want to sit there and keep plugging it in, you can just grab your little table and rock and roll. All right, so let's do the second example just to confirm. So we have, just kidding. I'm curious, I've never tried it if I do g of x. Let me see if it figures it out. I don't think it likes it. It's got an exclamation point. I might need to type it in as f of x, so don't get mad at me if it gets mad at me. I just need to check. I'm learning DESMOS right now too. Oh, it seems to not be mad at me. Okay, so I typed in g of x equals -2, and then our parentheses x plus 6. I'm gonna hit the gear icon, and I'm gonna convert it to a table. Now, I want to evaluate this one. So remember example 2, we did g of -5. So what this really is asking is, what is the y value when x is -5? So we're gonna plug in or check in our table, when x is -5, what is y? And you should see that as long as we haven't messed up, that we're getting the same thing. Okay, so same story here. Plug in your h of x, and then you would go and put -4 in the table, and that would show you for the next one what the y value would be. So that's another option. You decide what you like best. Do you want to use the table in DESMOS? I think that this is it's something everybody needs to know. Even if you are like, oh, I'm not going to do that, I'm just going to do it by hand. You need to know how to pull the table up in DESMOS, because we'll use it throughout the school year. Okay, so it's not like the last time you're going to see this. Okay, so y'all don't have questions about DESMOS, and you don't have questions about plugging in the numbers. All right, last but not least, so that I don't have to talk to you about anything else and y'all can just work. Last thing, it's a different type of problem. Evaluate each, all right, y'all gonna have to try to draw a graph. Each of the following based on graph of f of x below. All right, so this is gonna be a little interesting. This is the only reason that I wanted printed notes today, but we're gonna make it work. All right, so draw your XY plane. I think the easiest way to do this, so let's draw our little tick marks out to 5 in each direction. 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I think the easiest way to do this is to just plot points, guys, and then we're going to connect them because they're line segments for our graph. So the first point that we're going to plot is going to be at 4, -2. So 4, -2. The next point you're going to plot is at 2, 2. Then you're going to plot a point at -3, -3. All right, now connect them like this. We're going to connect. It's going to look kind of like an upside down V. All right, it doesn't have to be perfect. You're going to be asked on the STAR test for things like this. All right. Evaluate each of the following based on the graph of f of x below. So you're going to be asked to read graphs and answer problems like this. how you want to think about this, or what this is really asking, is what is y when x is whatever the value of x is. Because remember, guys, this notation, this f of 3, f of 2, f of x, that's another way of saying y. That's another way of writing y. Only we're being specific. Y, we're looking for the y when x is a specific value. So when x is 3, sorry, x is what I meant to write there. I just wrote 3. But when x is 3, what is y? So looking at your graph, when x is 3, so when x is 3, what is the y value? Yeah, 0. So it's from this ordered pair. So when x is 3, y is what? That's how you want to frame this expression or notation in your mind. When x is 3, y is what? And so in this case, yes, it's on the x-axis. So what's the y value on the x-axis? 0. So 0, exactly. And that's your answer. That's your answer. These are not difficult. They're just tricky and easy to get backwards. Can you stay for the rest of these two and then you can go? Okay, so f of 2. Try this next one. So when x is 2, right? So when x is 2, what is y?
Yeah.
When x is 2, what is y?
2.
Yes, it would be 2. So when x is 2, y is 2.
Wait, so when x is 3, y is always 0?
No, it just depends on what the graph is. But for this one, yes, but not like every time. You know, don't try to memorize it like that. But now, what are the value, and I say plural because sometimes you'll have more than one, but what are the values of x when f of x equals -3? Okay, we went backwards on you here, right? So now this is saying, all right, y is -3, right? Because this is just another way of saying y. So when y is -3, what is x? So now we need to go to the y-axis, find -3. It would be -3, but it's just because of the way that this graph, so don't think that these numbers always match. Obviously, they didn't here. But that's how you evaluate it. So when you're given this notation, your answer is the y value. If they give you they give you the x value, they're asking what is the y value. What is the x value that gives you that y? So it's just two different directions. It just takes some practice. So don't stress today about, if you get a couple of these backwards, it's very easy to do. But that is our answer, and it's x equals. So x equals -3 gives us a y value of -3 for this particular function. So you'll have a couple like that you'll look at today as well. So the practice problems for my online folks are in the practice folder in Schoology. So go to function notation practice. This is where you'll submit it. If you click on that, honestly, I linked it in there. You can just click on this PDF and open that up, and that's the practice problems. You can work it on notebook paper. My folks are here. You have a decision to make about whether you want to do these by hand or in DESMOS. I want you to download the DESMOS app if you have not. And if you can't, or if your phone's dead, or you can't use your phone, or you have a laptop or something, I really want y'all using DESMOS, because the more I talk to the higher ups here in the district, like that's what they're pushing as the online calculator. Like they want you guys using DESMOS. So as much as like it was weird to me to not give you guys calculators and have you using calculators in class, like they are pushing DESMOS big time. Yes. So I just don't want anybody to be at a disadvantage. Like I know some of the other teachers like are drilling DESMOS with their students. So I want to make sure that we are not at a disadvantage. with DESMOS. So use it today, please. That's what you need to be practicing on. I'm going to get our attendance ready here because we're about to